This is a very quick video in order to show a new approach to handling documents with images for our open source RAG solution. This approach is implemented in APR that we should be merging soon. So it will be available in the Azure Search OpenAI demo repo. So let's talk about what we're handling here. Here's a sample document. This one is a PDF that looks like it's been converted by from a PowerPoint. And you can see it's a mix of text and images, right? Some of the pages, a lot of the pages are a mix of text and images. Some of them also have tables, and some of them are only text. So how do we handle this for our data ingestion, right? Because for RAG, we want to be able to process all sorts of unstructured documents, PDFs, docx, etc., and store them as chunks in our Azure AI Search Index. So the new approach that we're going to use is that when you are handling a document with an image, during the ingestion process, we extract out the images using an option from Azure Document Intelligence that automatically recognizes when there are things that are image-like in a document. So it would, extract out this and say, hey, this is an image. It calls it a figure, right? So it extracts out this figure and this one and such. So we extract out that image. We then send that image to a multimodal model and say, hey, describe this image, give me a good description of it. We also at the same time compute a vector embedding for the image using the Azure AI Vision SDK, which is a multimodal embedding model. And so then in the chunks, we store both the text and the text that describes the figure. And then when we're searching, we can search both the text embeddings. We can also optionally search the image embeddings. And then when we send our question to the LM, we can actually send both the text that we described, but we can also go and fetch these images from Azure Blob Storage, because that's where we put them, and then send to the LM. So let's just see, right? So here we see this question here. Can you identify correlation between oil prices and stock market trends? And we look at supporting content. This is the results that came back from the search index that it used to answer the question. So you'll see like page, looks like page 9. Okay, so what you'll see there, future prediction trends, and then you see this is a description of that image that was generated from a multimodal model. But we also will get actual figures as well, right? So here's an actual figure, and here's a description of a figure. And then we also have some text-only things. We also have tables, right? So for the one that was a table, we got that full table. And so we can send both these text chunks and the image chunks to the LLM to answer the question. And the LLM can cite either of those. It can say, oh, I found the answer from the text or from the image. Now, if we look at the thought process, we can see for our RAG flow, these are the steps that happen. So the first thing is that we rewrite the user's question into a good search query, right? So it kind of, removes unnecessary words there. And then you can see we're using text search, vector search, semantic ranker. So we're doing a full hybrid search, and we're searching both the text embeddings and the image embeddings. These are all options that we can turn on and off in order to see how that affects the performance. For example, I actually don't think that you necessarily need to search image embeddings, because remember that our text chunks do have descriptions of the images, and I think that may be good enough for many use cases. But that can also be all be turned off, via the API, also via these settings, right? So we can choose whether we're going to turn off those image embeddings. So then we get back the results, and what you'll see is that for the results, we've got the text, and some of them contain these figure descriptions that are inside figure tags. And then some of these chunks have attached images in them. And you can see the images are stored securely in Azure Blob Storage. And each of those images have their descriptions and bounding box, which we can use. So we extract out all those all those chunks and all those images, and then we can send the original user question, right? So here's the original user question along with both the image matches and the text chunks, right? So this one's an image, this one's an image. It's base64 encoded since we can't give it an absolute URL for security reasons. And then we have the text sources as well at the end. So we send that all to the LM and we get back the response. Now you might be wondering, how does an LM cite an image? We have this great approach where we actually write the citation information on the top of the image. So you can see, here's the file name, and here is the specific figure within the file name. So that is enough information for us to have citations here. So there you go. That's the general approach. As I'm saying, as I said, you can turn things on and off. I suspect that many people could turn off image embeddings and get just as good performance because the text chunks do contain the textual descriptions of the images, but I left that option there for people who want them. And then you could also play around with whether you're sending the text sources and the image sources to the LLM. If for some reason you didn't want to send the image sources because you're, using an LM that doesn't support images or, for token cost reasons, you could try turning that off because once again, the text sources do contain figure descriptions. And for some use cases, that may be good enough. So I'm excited about this new approach. And, I hope with all these options that it can give people much higher quality results when asking questions about documents which have images in them.